All right, for our next unit for physical science, we are going to be talking about energy. Okay, so right now what we're going to start with, we're going to look at potential and kinetic energy and how they're similar and different, the conservation of energy and how that relates potential and kinetic. We're also going to look at different types of energy and see how energy is transformed in what we call a simple closed system. All right, so energy. What is energy? Energy is defined as the ability to cause change, right? So if something is able to change itself, or if it's able to change the environment, it has energy. Okay, so environment or itself has energy. We can also describe it as the ability to do work. Okay, so work or cause change is energy. When we talk about energy, so for force, we measure things in newtons. Now what we're going to do is measure energy in joules. All right, so that's a kilogram per meter per second is a joule. Okay, so what are the different types of energy? I already mentioned we have kinetic and potential, but what else are there? So if you look at this picture, there's a couple different things that come up, and there's going to be a couple more that we add later. So as far as what's going on here, we have mechanical energy, all right, so anything that's moving, thermal energy, so anything that has heat to it, electromagnetic energy, this is going to be dealing with light, anything that's infrared, so things below the visible light spectrum, and radio waves. We're going to get to this later when we cover waves with thermal energy in the next unit. We also have electrical energy, and that's lightning and power lines, so anything with electricity. We have chemical energy, so we can get that from food or like striking a match or any chemical reaction. And then nuclear energy, which is anything involving the nucleus of an atom. Okay, so here's a couple definitions for the different types of energy. So kinetic is the energy of movement, while potential is anything that's stored. Okay, these are the first two we're going to hit on right away. Mechanical, then, is the sum of potential and kinetic, so we're adding them together, that we use to do work. Okay, thermal energy, then, is the kinetic energy of molecules. All right, so this, when you measure thermal energy, you use temperature. So every time you're taking a temperature or something, you're actually measuring the thermal energy or the kinetic energy of the molecules. All right, our chemical energy is any energy stored in chemical bonds. So we'll get to that when we do chemistry after we're done with the physics part of physical science. Electrical energy is anything due to a flow of electrons. So electricity and other things are the way they are because electrons are flowing. Electromagnetic, as I said earlier, has to do with light, with electrical and magnetic fields. Okay, so those are going to be light waves and radio waves that we talk about later. Nuclear energy, that comes from altering the nucleus of the atom. Okay, and the last one would be sound energy. All right, so combination of potential and kinetic energy from air particles. So anytime you're hearing anybody talk, if you're listening to music, that's all from the potential and kinetic energy from air. Kinetic energy, so this is our energy of movement. So any time an object is moving, it has energy. Okay, so anytime it's moving, it has energy, and this specific energy is called kinetic energy. So whether that's me walking across the front of the classroom, this bowling ball moving down the lane and hitting all the pins, because those things are moving, they have kinetic energy. So we can actually calculate kinetic energy with stuff we've already learned about. So kinetic energy is depending upon the object's mass and the object's speed. All right, those two things are really important. And in this case, we're actually going to say speed is the velocity. Okay, so with a direction. All right, so mass, how much matter is in the object, and how fast it's moving. Okay, and the way we calculate this is 1/2 of the mass times the velocity squared. So here's an example. So if we have an eagle with a mass of 60 kilograms and it's moving at a speed of 3 meters per second, okay, we want to find the kinetic energy of the eagle. Okay, the way we do that is we write the equation, so KE equals 1/2 mv squared, and here's our velocity and mass. So then all you have to do is plug those in. So 1/2 times 60, which is our mass, and then 3.0 meters per second, and you have to square this whole thing. So that would end up being 1/2 times 60 times 9, since 3 squared is 9. And then that would give us total kinetic energy of 270 joules. Okay, so remember, we are not doing newtons anymore. We are now using joules and anything related to energy. Okay, potential energy. So we had a kinetic energy, which was moving energy, and now we have potential energy, which is anything stored. So this lovely little picture has a rock up here. That's got some potential energy because it's sitting stationary up on top of the cliff. So potential energy is the stored energy. And when they say interactions between objects, this just means because we have gravity and other things on Earth, this is what's giving things potential energy. All right. So there's actually a couple different types. Our main one we're going to look at is gravitational. All right, and that is the energy due to gravitational interactions. So if I stick something up on the side of the cliff, because it is further away from the surface of the Earth is going to pull it down. So if I would let it go or push it off, it's going to start moving. And the reason it can start moving is because there was energy stored due to gravity. All right. Our other two types of potential energy are chemical potential energy. So any energy that is stored in a chemical bond. So when we talk about chemistry later, you can have a chemical sitting there, and those bonds that are in between the atoms store energy. And then you can actually break those open so you can get the energy out. And then our other type is elastic potential energy. So anything that can stretch or compress, so like a rubber band, a slinky, etc., because they can stretch and compress, they can actually store some energy. It's kind of like when you pull a rubber band back and hold it. Because it's stretching, it's holding some energy, and then when you let it go, all of a sudden it can move. Okay, so how do we calculate potential energy? We knew we could calculate kinetic, so now we have potential energy. Now, because we're using gravity, and that's our main one we want to look at, this is how we calculate this. So, gravitational potential energy is related to the mass, obviously gravity, and how high it is away from the Earth. Okay, so that kind of makes sense. How big is something? What the gravity is of Earth, which is 9.8, or we can use 10 meters per second squared, and then how high it is or how far it is away from Earth. Okay, so if we have a 4 kilogram ceiling fan that is 2.5 meters above the floor, what is the gravitational potential energy of this system? So you write out your equation, GPE equals M, the mass, times G, times H. So the gravity and the height. So our mass was 4, so we put that here. Our gravity is always 9.8, or you can use 10 if you want to be a little bit easier. And then our height was 2.5. All right, so when you multiply all those out together, you get 98 joules of gravitational potential energy. All right, now we have something called the law of the conservation of energy. What this says is that energy cannot be created nor destroyed. Okay, very, very, very important. Okay, so we're not just going to create energy out of nowhere, and we're not just going to like destroy it somehow. All right, we can change the energy form, but the total energy is always the same. Okay, so this is where we're going to have transformations from one type of energy to another. Okay, so that mechanical energy is what's going to come into play. So we're going to do a lot of this where we're transferring between kinetic and potential energy and seeing how it transfers at different parts of the object and where it is. So if you look at this hairdryer over here, okay, when you have a hairdryer, if it's not plugged in, it can't do anything. So you plug this guy in. So in this case, plugging it in, because that's an electrical outlet, you have an input of electrical energy. Okay, now, when you turn on your hairdryer and it actually starts going, what you get out from plugging that hairdryer in, you take that electrical energy and you are going to transform it into sound energy, because those are quite loud depending on the hairdryer. Thermal energy, so the whole point of a hairdryer is to dry your hair, so you need some heat to do that. And kinetic energy, because all those air particles that are going and blowing on your hair are moving. Okay, so we put in one type of energy and we transform it into these three types. Okay, but the total energy stays the same. All right, so whatever we put in from the electrical outlet is going to equal the sum of these three things on the output end. All right, so that's our beginning intro into energy, and we're going to talk more about it and get more in detail in all these concepts.